Hello friends, I am from Chemistry faculty of QLS Academy. Today we are going to learn about extraction of metals from their site of occurrence. Hope you will enjoy today's class. So let's start our today's lesson on extraction of metals. In previous classes, we talked about reactivity of different metals. We saw the reactivity series of metals. Some metals were of low reactivity, some were of high reactivity, while some metals were of intermediate reactivity. All the metals are found in abundance on the Earth's crust only. But some are also found as soluble salts in seawater. The elements or compounds occurring naturally in the Earth's crust are known as minerals. Metals are found as their ores. Ores are the rocks that have a high mineral content, so high that a particular metal can be profitably extracted from it. Before extraction, the ores have to be cleaned. Mined ores contain many impurities like sand, soil particles, rocks, etc. These all are non-useful substances and are called as gangue. The separation technique applied to separate out gangue differs from ore to ore depending on the physical and chemical properties of the impurities and the metal of the ore. This process of removing the non-useful substances from the ore so that we are left with the useful substance only is known as enrichment of ore. It is the second step of obtaining a metal from its ore after mining. The extraction of the least reactive metals, gold, silver, platinum, is the easiest. Metals at the bottom of the reactivity series are usually found as their sulfide mineral, means in a combined state with sulfur. Like silver is found as silver sulfide, commonly known as argentite. Gold is mostly found in its native state only, but sometimes it is also found in a combined state with silver or mercury or with sulfur as gold sulfide. Similarly, copper and mercury are also found as their sulfides, and their extraction is also not a very difficult task. The sulfides are oxidized by heating them in presence of oxygen. Once oxidized, the oxides are reduced to their native elemental state by further heating. For example, when mercury sulfide is heated, it first oxidizes into mercuric oxide. When mercuric oxide is further heated, it reduces to metal mercury. In a similar way, copper is also obtained from its ore. The extraction of metals with intermediate reactivity is also not too much troublesome. These metals exist as their sulfides or carbonates. Intermediate reactivity वाले जो metals होते हैं वो as their sulfide और as carbonates exist करते हैं. It is easier to obtain metals from their oxides rather than from their carbonates or sulfides. So they are first converted into their oxides. पहले हम carbonates और sulfide minerals को oxides में convert करते हैं. The process of conversion of sulfide ores into metal oxides is known as roasting. जब हम sulfides को oxides में convert करते हैं तो हम इस process को कहते हैं roasting. Here the sulfide ores are strongly heated in presence of excess of oxygen, and as a result the metal sulfide oxidizes into metal oxide. For example, zinc found as zinc sulfide is heated in presence of excess oxygen, which gives out zinc oxide and sulfur dioxide. The carbonate ores are converted into oxides by strongly heating the carbonates in limited air. This process is known as calcination. Carbonates को जब हम oxides में convert करते हैं तो इस process को हम कहते हैं calcination. और carbonates को oxides में convert करने के लिए हम उन्हें एक limited air में, उनको बहुत ज़्यादा air supply ना देते हुए उन्हें heat करते हैं. For example, when zinc found as zinc carbonate heated in a controlled environment gets converted into zinc oxide and carbon dioxide gas. The metal oxides produced by roasting and calcination are now reduced to their metallic state by heating them with coke, that is solid carbon. During this reaction, carbon monoxide is released, which is a poisonous gas. So, as an alternative, metals of higher reactivities can be used to displace the metal from the metal oxide. The metals of higher reactivity like sodium, magnesium, aluminium can displace the metals of intermediate reactivity from their oxides by themselves getting oxidized and releases free metals. For example, During extraction of manganese, when manganese oxide is heated with aluminium powder, it produces metallic manganese and aluminium oxide. You can see that during this reaction, heat is produced. These reactions are highly exothermic. Such a great amount of heat is evolved that the metal produced in its liquid state, in its molten form. हमारे पास जो मेटल ऑब्टेन होता है, जो प्योर फॉर्म आता है हमारे पास मेटल का, वो मॉल्टन स्टेट में, लिक्विड स्टेट में आता है. This heat is used wisely for joining railway tracks and cracked machine parts. When ferric oxide is heated with aluminium, metallic iron and aluminium oxide is produced, along with a large amount of heat which can fix metal surfaces. This reaction is known as Thermit reaction. Now, let's see how can we extract metals of high reactivity. जो reactivity series में बिल्कुल टॉप पे है, हम उन्हें कैसे extract कर सकते हैं. We saw that for the metals of less and intermediate reactivity, reduction method can be used. पहले हम उन मेटल के ओर्स को ऑक्सीडाइज करके उनके ऑक्सीडाइज फॉर्म में कन्वर्ट कर रहे थे. देन वी वर रिड्यूसिंग देम टू देयर मेटेलिक फॉर्म. बट दिस मेथड कांट बी अप्लाइड ऑन मेटल्स ऑफ हाई रिएक्टिविटी. These metals couldn't be displaced by other metals because of their high reactivity. हमेशा जो lower reactivity वाले metals है वही displaced होते हैं by the metals of higher reactivity. So, the metals of higher reactivities cannot be obtained by simple chemical reactions. For those metals, electrolysis is used. Low and intermediate reactivity metals के लिए हम reduction method use कर रहे थे. अब high reactivity metals के लिए हम इलेक्ट्रोलिसिस यूज़ करेंगे. द मॉल्टन फॉर्म ऑफ द ओर इज इलेक्ट्रोलाइज्ड. जो हम ओर एक्सट्रैक्ट करते हैं उसे हम मेल्ट करेंगे, उसको हाई टेम्परेचर देकर उसको मेल्ट करेंगे. देन द मेटल्स गेट डिपॉजिटेड अराउंड कैथोड, द नेगेटिवली चार्ज इलेक्ट्रोड, while the other parts of the ore get deposited at anode, positively charged electrode. Why so? Why metals get deposited around cathode only? It is so because the ores are the ionic compound formed by combination of metals with non-metals. In last class only we studied that metals and non-metals combine to form ionic compounds, where metals are always the positive half and non-metals are always the negative half. Ionic compound form करते टाइम metals अपने electrons lose करते हैं to complete their octet and non-metals उन्हीं electrons को accept करके अपना octet complete करते हैं. It's all give and take relationship. So, the carbonate, sulfide, oxide, chloride ions are all negatively charged and hence get pulled out from the ore by the positively charged anode and thus releasing the free metal to travel towards negatively charged cathode. For example, when sodium chloride in its molten state is electrolyzed, it produces sodium metal and chlorine gas. So friends, now we have extracted the metals from their ores. Can we use these metals in this state only? Can we start making sheets and wires and objects of these metals? No we can't. These extracted metals still contain some impurities and are not completely pure. The best method to eliminate those remaining impurities is electrolysis. The final step of extraction of pure metal is electrolytic refining. We all know that metals are good conductors of electricity. So, the metals are made into electrodes for carrying out electrolysis. हम उन्हीं metals का use करके electrodes बनाएंगे और फिर electrolysis conduct करेंगे. The impure metal is made into anode. जो impure metal हमारे पास है हम उससे anode बनाएंगे, the positive electrode, while a thin strip of pure metal जो completely pure metal है उससे हम cathode बनाएंगे, the positively charged electrode. A solution of salt of the same metal is used as the electrolyte to pass the electricity. Now, when electricity is passed through this whole system, the atoms of the metal from the anode and also from the solution start moving towards cathode. जो भी जितने भी metal ions है, चाहे वो electrolyte में से हो या फिर anode में से हो, वो सारे के सारे cathode की तरफ move करना start करेंगे. The thin metal strip at cathode now starts to become thick and as more and more pure metal move towards it, the impurities earlier attached to metal starts to separate out. The soluble impurities remain suspended in the solution while the insoluble ones get deposited at the bottom of the anode and is called as anode mud. Copper, zinc, aluminium, silver, gold, etc. are all refined through electrolytic refining. So friends, this was all for extraction of metals. Today we learned how can we obtain metals and also how can we purify that metal to make it usable. In next class, we will learn about corrosion, the cancer of metals. Till then, if you have any doubt or need any further information, you can visit the following given link.